Whoa. Did that redeem work? I was AFK. Indeed. Hello. I haven't used the TTS button for my mic's up here. Let's bring that down here. Hello, everybody. I can promise I've done this before. Or at least so I believe. Oh, man, it has been quite the week. And it's only Wednesday. So that's mighty interesting. How are you all doing this evening? Let's see, who do we have here in chat? SB, Pyro, Thunder. Hello! Oh, wow. Like, gasp. Thank you for the resub, bud. It's appreciated. Like, gasp. Oh, wait. I'm bad at reading. Thunder gifted. Yes, Thunder, it's okay. That doesn't mean I can read. See, what kills me is that the overlay says that Pyro resubscribe, but when I look at the activity feed, then I see your name gifting the sub. I screwed this up the last time I had this happen. Yes, I will accept the fact that I am stupid. That's part of the Thank you for gifting the sub, Thunder. It's appreciated. Let's try that again. Oh my word. I'm so bad. No, see, it's lies. It's lies because you see live the name of the username in who the sub goes to, but on another screen above my head, it indicates that it's give sub. Does that actually show that over here? Yeah, it shows it over here too. Okay, so one of the screens is lying and the other two are correct. So naturally, I'm looking at the wrong one. Love that. All right, well, the fact that I can't, read basic words surprises no one, including myself. That's okay. We're going to get into it. All right, so over the next couple of streams, oh, that's right, PayPal. I forgot. Oh my god. Wait, what? You can't sign in, but you can spend money? Well, we know where their priorities are. That is all kinds of crazy. Oh my word. Okay, so here's the attempt at the roadmap over the next several streams. I got my hands on the sensor pack. I bet you are. I am too. We're here for two things tonight. One, we're gonna dip into the sensor kit. I'm 100% expecting. I looked through it. Some of these sensors we've seen before. A lot of them we haven't. And I figured we'll cover a sensor, and then we'll work on proto head stuff. Because what my planning is, there's not a whole lot of show and tell in the initial stages, but there's a lot of things to think about, decisions that have to be made, and kind of general gathering of resources. And really what I want to do live with the proto head in the initial stages is work through the thought process of what kind we're going to use, what kind of PLA we're going to use, maybe find a direction on code and screens, things like that, like the actual planning that goes into it. Because once I got a plan, then we'll have parts, and then from there we're making stuff. But I couldn't make up my mind on. I didn't want to omit the part of figuring that out, because I like when the process starts from the beginning. And I very much plan on uploading the Proto Head Babble up to my YouTube channel, so that if anybody wants to rewatch how I got from where I am to where I'm about to go, it'll be there. Exactly, blueprints. So yes, tonight is going to be a lot of rambling, but that is going to hopefully further us in the correct direction of where we need to go. So let's jump into it. So first things first, we are going to do stuff with sensors and Arduino stuff. Part of the reason why I'm kind of happy that there's a little bit of this is a revisit, because I really could use a consistent reminder of how this stuff works. Because if I'm going to want to build off of the thought to make my own stuff, then I need to make sure I remember the basics. So that's okay. So we are going to swap into, let's see here. Well, that one. Aha. So from what I saw, some people are using pies and some are using daisy chained together Arduino boards, but what's daisy chained together are the displays, not necessarily multiple Arduinos. So it seems like there's like one sole controller for multiple screens that are all attached together, or at least that was one of the configurations I saw. But yeah, we're gonna get there. I am excited and terrified at the same time. I have no idea how entertaining the second portion of this is going to be, but it's going to be fun for me. So anybody who decides to stick along for the ride, hey, cheers to you. Because I'm going to tell you right now, I don't know how it's going to go, but we'll see what we can do. First things first, with whatever sensors, I appreciate that. Whatever sensors we have here, I know several of them are going to require libraries. And look at that, my plugin updated. Good job. And looks like KY001 is the temperature sensor. Well, let's expand this out. Fancy that. Okay, that's a broken image. Wait, was that supposed to be the diagram? I think that was supposed to be the diagram. Well, shoot. Is the diagram over here? Nope, it's broken here too. Cool, we get to fly blind. That's fun. I don't want your stinking wiring diagrams. Yes, I kind of did, but you know what? That's okay, we'll figure it. I can't be that bad. It's one sensor. There's going to be a control pin, power, and ground. That was be all I'm going to imagine we're going to end up doing. Why am I not even remotely surprised by this? What do we got here? Reload image. All right, curiosity has me. Ah, I see what happened. So this is a file. This is an image file that points to their old domain. So Crafting Table rebranded themselves. They used to be inventor.io, and then they rebranded to craftingtable.com, which fair. But the problem is that when you change where all your stuff lives, if you have hard-coded links, aka the broken picture, they stay broken when you transition to a new server space. So that is absolutely supposed to be a wiring diagram, but that's fine. We'll get through it anyway. All right, so we're gonna swing past the code here for a second, and I can see here there's a complete. Oh, look at that. The video says it's private. Interesting. I might not even be able to load the educational content that goes with this exercise. Well, that's fun. Is the actual download over here, or is that broken too? Interesting. Okay, so it just points to the same stuff. Yeah, we got this. I'm convinced that if they don't tell me what library, we'll be able to figure it out. The only thing I would have wished is if I had a picture of which sensor is the one we're supposed to play with. But you know, we might have to figure that out too. Well, that's okay. All right. First things first, I am going to pause the music, and we're going to see if the educational content even loads. So, I got that sorted. Let's see if we even get anything here. All right. Well, at least that's working.
All right, so for this one, we have a temperature sensor. It'll look like this, and the wiring is really simple on it. Negative, middle one's positive, and
Okay, hold up. I'm going to pause that real quick and find that. Yeah, that was loud in my ears. I can imagine that was probably pretty loud for all of you downstream. That's a temperature sensor? I thought that was a... I definitely didn't think it was one of those. All right, bear with me a moment here. Because if I let it play, I'm just going to have to go back to trying to figure out which one of these is the right one. So let's see. This is... Try to get that a little less blurry.
the wiring is really simple on it. Negative, middle one's positive.
This antennas are for ears. Hey man, you don't know, neither do I. This is gonna be a really fun game. There's a lot of stuff that's yeah. So I have a pile of all the sensors, and I'm going through them. And I'm gonna tell you right now, I kind of wish the parts were labeled in some capacity. Because I mean, some of these I can identify because A, I've seen them before. But B, some of these, some of these do not. Some of these don't quite look the part. It might be this one. QC. Well, realistically speaking, I don't think I could technically damage any of these, per se. As long as I don't plug voltage into the wrong side of these things. Interesting. It would appear that I have two of those. Do I have... Oh, no, wait, maybe this is it. This looks more like that, I think. Famous last words. Yeah, you're telling me. I'm over here trying to make heads or tails of this. Okay, I think I found it. Yeah, okay. It's bent in a similar way, which, yeah. Hey, now hold on a minute. I know I could damage things. I just think that with the low voltage, I don't think I'm capable of doing too much serious damage to these little sister boards, but who knows? I'm a special kind of proto. All right, I think I found it. We're going to continue here.
And then S is going to be for the value signal. So let's go ahead and wire this up. Now I'm going to send my signal all the way over to 10. 8, 9, 10. Middle one is going to be positive 5 volts. And then that's going to go to ground. All right, let's hop into the computer and I'll show you the effect of this. I can't show you anything here. You won't really see.
Right, so data went to 10. And then data was S probably for serial, I bet. And then the negative line is green and the orange is positive 5 volts, which is the center pin. Okay. Well, let me keep chatting here and see what we got.
See anything, but I'll show you inside the serial monitor. Okay, as you can see, what we need to do for this one is a little bit different than all the other ones. This one we actually need to include. So this one's cool. What we go up here is we go.
Does that mean we'll have a breadboard in your head while you solder the wires? Because if you use breadboards, you'll truly make yourself a toaster. Hey, now, anything that ends up going into my head is not going to be connected to a breadboard. It's going to be something more permanent. I don't need bread coming out of my head. I have emotes for that, but we're not doing that.
Let's see if I can get it. Include library. I don't think that's what I'm looking for. And libraries, that's what I'm looking for. I'm used to the Windows version. So let's go ahead and look.
Exactly.
One wire. So as we see here, Let's go ahead and install this one. We're also supposed to install Dallas Temp, I believe. So I'm just going to grab that one just in case, make sure that's the only one. Let's go ahead and install that.
Dallas Temp and one wire. Okay. DALLAS would be help if I spell LL. Yeah, Dallas Temp. Okay. It's also by Adafruit, which is very popular in making these developmental boards.
Let's try this again. Perfect. So that'll work. And now we want to make sure it's on pin 10. So let's go ahead and open up.
All right. All right, I feel pretty good with that. I don't really think we need the rest of that to get ourselves off the ground here. Since we didn't have a diagram, we flying blind. That's okay though. Okay, so first things first, I'm gonna put all these extra sensors away that I fished out of this little box so that I don't accidentally grab the wrong one. I find it interesting that I appear to have more than one of the same thing here. A couple of these I only have one of each, but a couple of these look like I got more than one. Also, I don't know what's going on here. It really looks like they sent me some bulbs that have mercury in them. Unless this is another substance, which I'm really curious to see if they tell me if it's something different. The reason I say that is because mercury can't be mailed in the US, and that would be bad. Or at least it can't be with without proper documentation, which is fun. It's like a serious crime in the US if you use the postal service and send mercury. It's like $180,000 fine or something ridiculous. So yeah, don't do that. Definitely don't do that. Yeah, mercury, exactly. It's delicious. Mildly nutritious. Alright, excellent. Alright, so I'm going to get us over to the bench. Alright, cool. How much to mail plutonium? You know what? I feel like you need to know a guy if you're going to do that. You know, something about a time machine? I don't know. It'd be what it is. Okay, so since this does permit reusing the same board that we had for the previous exercises, because it's supposed to be an add-on kit, we're going to unhook our lovely setup from last time. And as I had mentioned, I believe I have found the right one. I'm pretty sure it's this one. It looked an awful lot like the one that they mentioned. Oh, snap. I need to bring Chad over here. Haha. Do. This one. And I want to go here. And I want to go here. Nope. I want to go here. And I want to go here. All right, cool. Yeah, it's better. I can see everybody now. All right, cool. Good. Bring my little stand over here. Excellent. All right, good. So I got that out of the way. All right, so what we've got from the previous time was our little spaceship action thing that we had going on here. This we're going to just disconnect, and then we're just going to reuse the board. Obviously, that's what we're gonna use the hero board here. So I'm going to take a moment, disconnect all this, and then we'll get started with tonight's exercise. Alright, cool. So buttons out of the way, and we're gonna get the several segment display out of the way. This is the push-on style connector, which we're not too worried about because we don't need that. And what we will need is a good majority of these little dudes that are just kind of sticking out of the woodwork here. So first things first, we're going to clear our board up. All right, cool. What will we use the sensor for again? I can't recall. Oh yeah, no worries. This is a temperature sensor. Supposedly it can read temperatures, which kind of blows me away, to be honest with you. It doesn't look like what I would picture a temperature sensor to look like. I kind of would have thought it would have looked something a little bit more with almost like a reflector or something. It's kind of hard to explain what I had pictured in my head does not match up with reality. And to be honest with you, that's a fairly common reoccurring theme. when you haven't seen hardware before that you need to use, you may have different expectations from what you end up seeing, and there's nothing wrong with that. It's just keeping it in mind. It may not look the way you think it should. Exactly. No, so my thought process as to why I want to go through the sensors is in case we come across something that would be really cool to build into the proto head, we're going to figure that out as we go along through the conversation while also continuing to tinker with this stuff. Can't see that. It's almost like I'm trying to plan I'm trying to plan for stuff that I don't know and kind of bring us into it. Because how can you possibly plan for something that you don't know when you don't know? You don't know what you don't know. And I'm going to pretend that that made sense. Built-in lights in the eyes so you can light the way in the darkness. Indeed, super spoopy. Love that. So I've got two major plans that I want to do, but I'm going to save my words for that segment of the stream because I am going to chop this VOD up. And don't worry, we are going to get there. I feel like it would be kind of stupid if I put it in the board like that. I also don't want to overbend the sensor and risk breaking these because I really don't want to have to break out my solder. Alright, let me see where I'm at here. We've got the negative, which is the green one. And then the positive 5-volt rail is going to be, I believe, the center. So then we'll plug that into 5-volt. So far we've got these two hooked up. And then what my plan is just to feed the power through the rail here so that it'll be, you know, breadboard or developmental board to breadboard, and then it'll feed the sensor. That's kind of the thought process. And then as for our data line, since there's a convenient break in the electricity between these two segments of the board, I'm just going to put the data line in one of these so that I could just plug pin 10 on the Arduino right into here so that it keeps this a very nice, neat little loop. So then I don't have to have as much spaghetti in the immediate area. We're gonna have some spaghetti, just not as much. And then we're gonna connect the two together. Now, assuming that I selected the correct sensor, this should get us the distance. Now, conveniently, I did have two purples, so we're gonna use purple to stay with the data colors. And then blue will be 5-volt, and then white will be ground. So then I have something that looks like this, and then these I get to plug right into our board. And then we'll fire it up and see if I have anything in the right position, let alone the correct sensor. I think I do, though. Oh shoot, you know what? I don't know if that's 3.3 volt or 5. We gotta check the video again. Let me switch us back over to the video. Because I said 5 volts. I don't know if that's what the instructor said. Let's double check that. Yeah, we're gonna check that. Let's go back this up a little bit here and let it play that section again. Yep, I can see it right there. 5 volt. All right, good. So we have 5 volt ground, and then 10 is a PWM pin or a pulse with a modulation. For those that like longer words. All right, cool. All right, so we are indeed playing with 5 volts, which is mighty fine. All right, so blue is going to be our 5 volts. And then ground 5 volts. Right there. And then the ground is going to be white. And then purple's our data pin. And that we're going to plug into pin number 10. So we got 8, 9, and 10. Alright, cool. So realistically speaking, this should be the layout. So we've got our single sensor down here on the end, and then we're just passing power and then a single pin to read data. Now, I haven't reset the code from the previous exercise on the board. So first things first, before I plug this in, we're going to get up a blank sketch. We'll upload that, and then we'll start tinkering. Satanic, that was really good timing. I literally just tossed my headphones on, and then I had applause. So thank you for that. Apparently my tracking has lost me. Please stand by. Indeed, apparently we're doing rotational things. Whoop, there we go. Yeah, he's got to really stretch those shoulders. You never know, right? All right, cool. All right, so yeah, we gotta get up a blank sketch here. I'm known for impeccable timing. Indeed. Yes. Good coffee emote. That's a fun one. Okay, so we're gonna minimize this. Those should supposedly be the libraries we have to pull over here. And then this is going to open up the previous day of the 30 Days in Space franchise. And then we're going to make a new project. Alrighty, so we're going to do file, new sketch. Okay, and then we're going to go to Arduino. I'm debating if I want to subfolder these. Actually, hang on, let me do a small amount of cleanup here before we get started. Oh, you know what? I'm not going to move them. You know why? Because there's libraries that are in this folder. So, you know what? I'm not going to mess with that. Got my emotes done by Yin King. And I have absolutely no idea how he nailed my smug ass face when I'm sipping coffee. Because he's never seen me before. You know what? That makes for a really good artist. I've seen Yin King's work. Very, very nice. Matter of fact, I actually think their commissions are open the last time I checked. Yeah, alright, we're just gonna make a new folder in here. I'm really not too worried about it. As long as they stay subfoldered, it won't be that big of a deal. Oh, you know what? I just thought about it. It's going to make the folder. So here, let's get rid of that. And then we'll just name the sketch. So this is going to be 37 and 1. 2. Sensor. That will help me remember what activity this is from, because it's the multi-pack of sensors. Okay, so now that I have this up, open back up in October. Oh, okay. I'll think about first posing them to being one of my channel artists. Hey, there's nothing wrong with that. My new art's kind of stalled out as of late, so I'm waiting on a couple different folks. So we'll see who gets there, who gets to the end first. Life has has funniness like that sometimes. Good art's worth the wait though, so you know, it'd be mighty fine. Indeed. Okay, let me plug the board in, and then we'll get the blank sketch uploaded. So let's get that going. Well, good news, I plugged it in and no smoke came out of anything yet, so it's good. All right, so first things first, we're just going to upload the blank sketch. All right, good. So that'll clear all the code that was on there from last time. It doesn't clear what's in the memory addresses though. But it's okay. We're not writing or reading to them. We're not using them right now, so I'm not worried about it. My headset died, so I have desktop. No. Oh, well, that's a bummer. Oh, fancy that. We got a watch streak. Neat. I haven't seen that before. That's cool. PTSD. Hey, the reality is, to make a cool proto head, we gotta look at code, okay? That's going to help us make the super fancy blinky thing. Or at least I hope. I'm very much reaching out into territory I don't know a ton about, but that's never stopped me before. And it's not going to stop me now. Go to bed. Welcome on in, Mr. Green. My God, for you, it's got to be like the middle of the night / morning. I do appreciate you popping in. By all means, stick around as long as you feel like staying. Hello. Oh, my word. No, I will not. 2 a.m. gang. Hey, it's not 3 a.m. That's not time for a Krabby Patty quite just yet. That's okay, though. Oh my God, that's funny. You've made me smile. Thank you. Thank you for that. Okay, I'm gonna do the same thing I normally do. I'm just gonna bring the code over and then we're just gonna dive into it. That helps me help you help me. That's how that works. All right, cool. I'm also going to nab the comments because we're going to be really diving into this since we don't seem to have a lot to work off of here. All right, grab all of our curly braces, have my hand do weird things because the sensor's being weird. All right, now I didn't include any libraries yet. Let me verify and see if it's going to bark at me. Yeah, okay, we got to install libraries. That's fine. 2 a.m. gang. Yeah, it's a good way to find friends in the same time zone as this crazy platform called the internet. It'd be wild. All right, let's see where we're at here. All right, so this is lesson 001, temperature sensor. The KY001 is a simple temperature sensor module that measures ambient temperature using a DS18B20 digital thermometer chip. That chip is a one-wire digital thermometer chip that is often used with the KY001 temperature sensor module in electronics projects. That particular chip provides 9 bits to 12-bit temperature readings in Celsius, with a temperature range of -55 up to 125 in Celsius. Temperature accuracy is within half a degree in either direction, in the range of -10C to 85 plus. The chip communicates with microcontrollers using the one-wire protocol, which allows multiple of them to be connected into a single microcontroller pin, making it a cost-effective solution for temperature sensing in various applications. Libraries required: install the one-wire library from the Arduino IDE library manager. So the one-wire library, that's what we're gonna go get. hey, don't be giving out locations in chat. I'm pretty sure that breaks the OS. I don't want to see anybody here get in trouble with the super mods. Let me see here. One wire, look at that, boom, and install. Good. Well, we're gonna grab that, and then I'm going to click verify again and see if there's anything else it wants me to go grab. All right, cool. So pretty easy. So it didn't need the other library that they mentioned, the Dallas temp, which, so the thing is, I'm imagining that we probably could if we wanted to, but Okay, Thunder, you win this round. That's pretty good. You know, I don't think you're wrong. I love how close we are and yet far away we are on planet Earth, but some parts of planet Earth really do feel like another planet. It'd be like that sometimes. This doesn't seem like to be much of a discrepancy. All right, cool. Well, good. We have the library we need now. And actually, something I do want to check, since I didn't put this in another subfolder, to see if we look in the libraries folder that's in this folder. Does it exist in here? Yeah. Yeah, that's today's date. So yeah, that is in fact the library. We got a keywords thing. What's in here? Ooh, so these are the keywords for the library. Cool. Nifty. Even my friends from Germany don't know it exists. I was making it up. Hey, that means you could be as secure as you can be. That's the level of anonymity some people look for in this world. They'd be hiding in the middle of nowhere, but everywhere all at once. Love that. All right, enough of my own shenanigans, at least for now. All right, let's see here. All right, I believe I think I've got this hooked up right. Again, I don't see smoke coming out of anything behind me, so that's good. That's a good start. All right, so just like we have before, we include the one-wire library. Now, I don't see the Arduino IDE call in here, the include for that. It's not technically required, but I want it. It's a general assumption because we're using this specific IDE that this is supposed to be assumed, but I'm gonna be real with you right now. In computers, no one ever assume anything, because if you did open this in a different IDE that wasn't this one specifically, this would no longer compile. By telling it to use this include and including it, that makes sure that if we do open this in a different editor that's not this one, it'll still work. That's why we're going to include it. And then we have our one-wire protocol. This is going to be, or excuse me, the library, the one-wire library that we need to be able to interact with said sensor. Now, what do libraries do? Libraries allow us to use code that was written by somebody else to make our project less code intensive. I'm sure there is a way to directly interact with this chip and read the stuff in it, but without the library, that means we'd have to make all of the things, like interpret the readings, make sense, well, not make sense of them as interpreting them, and anything else that would involve reading that information, because we're not writing it to anywhere, and that would just be in code. But by using a library, it kind of speeds up the process. Yeah, the incompatibility between compilers. Yeah, that's the thing that kind of scares me a little bit. Before I got you, that is. You two are goobers. But you're in my chat, so you're my goobers. Alright, let me see here. Alright, so debug is set to false. Set to false and use serial plotter for graph of all temperatures. Interesting. Alright, so let's do a little reading here of our comments and see if we have to switch anything around. Someone has to be silly. You know what? You're not wrong. We specifically plugged in the pin 10, but since our lovely instructional material has a broken graphic, I'm going to trust nothing. We'll have to check to make sure that the code matches up with where I plugged stuff in. Always a goober. Never know your next move. Banana for scale. Got him. Yeah, you know, it's fair. I could go grab a banana from my kitchen and use it for scale. Maybe we'll do that. Maybe we won't. The silliness will provide. Let me see here. I'm gonna derail myself so bad tonight. I can already feel it in my bones. This project just needs a digital pin. All right, cool. So digital pin is PWM pins, like pin 10. On the Hero, Arduino, Uno compatible, we could use D0 to D13 or A0 to A5, which are the analog pins. Skip A0 to A5, save for analog. D0 and 1 used by USB. Right, those are the data transmit pins. For scale, yeah, of our electronics. What else would I have on camera? That's what we got. D2 and 3 is safe for interrupts. D13 used by LED built in an SPI clock. Right, because D13 data. And then 5, 6, 9, 10, and 11 are safe for PWM, which is what we need. Well, technically it just said digital, didn't necessarily recall for PWM. Hey now. I'm watching you, watching me watch you. That's what's happening right now. All right, interesting. So D11 and 12 is SPI for MOS I and MOS ISO. So this is the kind of stuff here. This is actually really helpful. There's this little blob of information here. Because I recognize all this stuff. I'm not really sure what's going on here. SPI, SI, and SO. Recommended for fused complex would be D4, 7, or 8. Well, D10 is the one that we chose, so which one did we end up with here in this thing? 001 pin equals 4, good digital pin, not used for other purposes. This pin number 4, so... Interesting. I'm not going to change anything yet. We're going to just keep reading and seeing what we might come across here. Let's see, one wire library and communicate. It's a DS18S20. Oh, it was an S, not a 2. Got it. Temperature chip. One wire DS. Create one wire object to communicate with the sensor. All right, cool. We pass it the pin. Create the one wire object to communicate with the sensor. Each one wire sensor is configured with a unique 64-bit address, starting with an 8-bit family code, 48-bit address, and an 8-bit cycle redundancy check, or CRC. Checksum to validate that the address reads as no errors. Since we have multiple DS18x20 sensors on the wire, we will pull for all devices on the wire, validate, and identify each and save the addresses of all of the DS18x20 type sensors here. I don't know about you guys, but I had one that I just fished out to plug in here. Max DS devices is 5. We will save addresses for up to 5 sensors. And then we have DS address, 64 bits for each address, which is fine. That's just to hold the address. Functions to print a 64-bit number in hexadecimal, which is print address. Okay, so this is to see the actual physical address to give the sensor. 8 bytes or 16 bits. All right, cool. So we are going to use the serial monitor, so I will make sure to make that visible so we can see what kind of stuff we get in there, which makes sense because that's probably where we're going to spit our stuff out since we're not working with the display tonight. And then we're going to scan the one wire for all devices, saving all of the DS 18x20 device addresses. So then we're going to hop into a loop. This is definitely not going the direction I thought we were going to be going in. I thought we were just going to be reading a pin with a simple loop. This is way more involved than I necessarily thought this was going to be. Now, granted, this is written with the assumption of multiple devices, which I'm not quite sure how that would work with one wire. But I mean, the library is called one wire, so probably something to do with that. Oh, God.
Bob, can I get a glass of water?
I would agree. Thank you. I have delicious tea tonight. It's apple cinnamon. It is delicious. It's good for all times of the year, but it seems to make even more sense around the cooler, spooky months. Indeed, indeed. Alright, cool. Alright, so we don't have debug on right now, so this if statement won't do anything. When you have a variable inside of an if statement with no other parameters, this simply means if true or if false. So since it's set to false up top, then this won't run. Oh, well, that's fair. Searching for valid devices. And then we have ds.search. Create one wire object to communicate with the sensor. Look for the next device. Returns 1 if a new address has been returned. 0 might mean that the bus is shorted. There are no devices, or you have already retrieved all of them. It might be a good idea to check the CRC to make sure that you didn't get garbage. The order is deterministic. You will always get the same device in the same order. That makes sense. Juice and water. Well, that's okay too. So we're going to grab the device address. And then we've got, right, if debug, we spit the address out. We're going to end up turning the debug on. Oh, excuse me. I'm just going to rock and roll with that. Okay, we've got serial print line. CRC8, compute a Dallas semiconductor 8-bit CRC. These are used in the ROM and scratchpad registers. So it looks like we're going to actually take the address and increment through all the ones we have. Yeah, there's a lot of if statements. This is a lot more code than I thought there'd be for one sensor. But again, this is a structured exercise. I'm sure you could probably just read the value of that chip with a lot less code if you really wanted to. I'm not gonna lie, I kind of thought this part would be fairly quick, but no, not so much. Not that it's a problem, it's just a little bit more than I would have thought for a guided exercise on a single sensor. So hey, that's how we learn, right? Serial print line CRC is not valid, skipped. If the debug is on, yeah, I am in for a long ride. I already know what the proto had. I'm going to be in for quite the experience. It's going to be interesting. And then from here, we're going to switch through the addresses. If debug is on, we'll print the name of the sensor. And then, so the cases here are different return values. So if the case is 0 times 10, or 0 times 28. Then this looks like it differentiates between the different subletters of this sensor. I greatly appreciate that, Thunder. I can imagine this entire project is going to be very community centered anyway. From what I can figure out, from what y'all can wander along, to be appreciated. Listen, this code already looks haunted enough. The audio just confirms it. I'm just saying. Honestly, it's the right time of the year for that redeem. I'll tell you that right now. Alright, so this must be the beginning of that unique identifier based on which subletter you got there. That's what that seems to be about. It is appreciated. Continue for loop with next device. Right. Valid DS 18 by 20 device. Point to the next address. Right, to just count. Else we break, no more devices, and then a little bit of a delay. Spit it out to the screen. If the DS count is 0, then just return nothing. Now that's all before the void loop. Alright, that's void print address. Oh, that was all a setup. Okay, so this is all set up here. Where we can run through the debug just to, I guess, quote unquote. Excuse me. That's kind of just standing everything up to look for them, and then we're going to use them, which seems interestingly enough. And then down here in the loop is us actually getting readings. So seeing here that this oh, fancy that. Hello, Xenor. Welcome on in. I don't know what happened with Automon. I don't know, because there's literally nothing in that statement. I don't know. It triggered the smart detector. It doesn't say why though. It just says that it didn't like the phrase. It's okay. I got you, Les. We'll be okay. It's all right. I mean, if it thought you were trying to run like rogue code or something and check, maybe that's what it was picking up on, but I don't know, it doesn't look like it's bad. I don't know, maybe the stars that triggered it. I don't know, I'm not too worried about it. I got you. Oh, did it? Oh, if you didn't type those stars, then yeah, okay, I could see that. Yeah, we're all right. We're all right. We're okay. It's all right. Xenor, have you ever played with temperature sensors before? Because what I thought was going to be a fairly straightforward beginning section of this stream turned into quite the deep dive. I think I tripped and fell into the deep end. I mean, it doesn't feel hard what we've done thus far. It's just a lot more code and setup than I was initially anticipating. I thought this was going to be something similar to the light sensor, where we're just kind of mapping values. This has turned into quite the little project all by itself. Nice. Oh, okay. Oh, yeah, cool. Well, after stream, I'll check my DMs. Thank you. Oh, excuse me. Blah, 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 blah. I got lost here. Okay, so yeah. All right, so we're starting the loop. There's that right there. And then from here, we're going to tie with some integer values for conversion of raw data to C. High byte, low byte, key reading, sign bit, DC100, whole, and fract, which is probably for fractional values. Okay. Man, this is crazy. Byte data. No, interestingly enough, it's a digital pin. It's a digital sensor. It's the hang on, let me scoot back up here. It's the DS18B20 temperature digital temperature check, and it runs off the one wire protocol. Body pine, welcome on in. All right, so DS18S20. You know what? I don't know if it's from Adafruit, because this is one of the sensors that was included in the 37-in-1 sensor kit. Which is this one from inventor.io/crafting table. And it's got like a bunch of stuff. It's that. Only 4 pins, interestingly enough. Oh, wait, did I say 4 or 3? 3 pins. There's data, ground, and 5 volts, according to what we've seen thus far. So that's interesting. Blah, blah, blah. Yeah, you got it. Oh, let me see where I'm at here. All right, so here's our loop. The DS18S20 supports having multiple devices on the same wire, each returning their own address each time through the loop. We will find the next module and retrieve its data. Okay. I think something shorted out of my head. That is wild. That would make a lot of sense as to why it's called the one wire protocol, or in this case, the one wire library, because you can have multiple of these on one data line. That's fascinating. I feel like I'm gonna be able to break this in a hurry. That's exciting. So for I equals 0, we're going to do a loop, add separator if not in debug mode. Right, ds.reset, perform a one-wire reset cycle, returns 1 if a device responds with a presence pulse, returns 0 if there's no devices or the bus is shorted, or otherwise held low for more than 250 nanoseconds. I think that's US. Fair enough. For those of you who just wandered in here, I don't have a wiring diagram to show you because the image is broken on the website. So we just kind of followed off of what we could find on the video that's included with the sensor pack. I have to say, right now it's feeling a little lackluster, that it's kind of a little broken. I think I have it wired correctly, but we're just wandering through this as it goes. All right, let's see here. Since we supplied 5 volts, we don't need to supply the parasitic power and weight. Interesting. Issue a one-wire ROM select command. You do the reset first, which we did do the reset first, and then from here, it looks like we just cycle through the addresses. 64 bits for each address. DS write 0x44 false, ground to ground, VCC to VSS with a 4.7K resistor connected to the data pin. Interesting. They didn't mention that in the diagram. All right, well, 4.7K resistor. Interesting. Let me actually put that. You know what? Yeah. No, that's fine. I'm actually kind of curious to see with the way it's wired based on the video, just to see if I'll get anything right now at all. Because right now it's hooked up, and so far it still seems to be in one piece. Might do a DS depower here, but the reset will take care of it. Perform a 1-wire reset cycle, returns a 1 if the device responds with the presence pulse. 0 if there's nothing there, we're shorted to nothingness. Right, okay, so ds.write. Write a byte. If power is 1, then the wire is held high at the end for parasitical power devices. You're responsible for eventually depowering it by calling depower or doing another read or write. And then here we've got what would appear to be a memory address. Read scratch pad is the note. Alright, so if debug serial print data is right equal to some spaces to make it formatted so it's a little pretty. We need 9 bytes. Read the next byte. So it looks like we're reading and we're just wandering through what memory addresses we've stored and then checking them, if I'm understanding this correctly. Alright, so it looks like here if we do some debug, we do check the data, and then let's see, CRC8. Alright, so we're taking the data and then checking it to see if it's valid or not by running it through an 8-bit CRC check. And then from here, we just check to see if it's valid. If it's valid, I'm sure we're going to display it here. If not, looks like poor things happen. So again, if debug is off, that's ignored. Right, if CRC is not valid, return nothing. If the debug, then you're going to print a blank line. Otherwise, we're going to, yeah, that's if debug. That's all one line. And that's from there to there. Interesting. So if it's not broken, then we don't quite do anything. At least not right there. We go T reading is equal to the data. Get 16-bit readings from first 2 data bytes. I'm not familiar with that comparison operator. Let me see what that is. Arduino programming, the double left arrow symbol represents a left bit shift operator. This operator shifts the bits of the left operand to the left by the number of positions specified by the right operand. New bits shifted in from the right are filled with zeros. Okay, so it's a shift operator. Cool. At this time, seen or nothing, I don't quite need. I'm just kind of processing and wandering through this. I pride myself on not looking at the exercise ahead of time, just so that it's, well, genuine, and if I get lost, I look stuff up. I might not be able to continue doing that forward, but you know how it is. You're distracted because you're reading the data sheet, and that's okay. Alright, so then all this means then is that we just shift by 8 bits to get the next data in line here, and we just add in the position, shift by 8 bits, and then go again. Okay, alright, cool. And then if debug, we do that. That ends the primary loop, and then down here we have a function called print address, which we can call upon, which I'm sure we do that in debug, which makes sense. And then that could spit out to us here our address. I had no idea that you could actually have multiple things tied into one wire, which again, I get it, it's the name of the library, but like that like blows my mind. Now again, that requires a pretty decent understanding You're confused as well. Yeah. Well, the concept of that makes sense to me, because in the concept of that, you're taking multiple devices plugged into the same wire and you're reading them all by giving them unique serial addresses, and then from there you're able to check that. What I don't quite understand is how you're capable of serializing each of the sensors on one wire. Like, how do you distinguish that? I'm just confused how you write to it. Well, you technically shouldn't be writing to it because it's a sensor that you're reading data from. There's no output on it. You can read and write. Wait, hold on. The data sheet says you can read and write to the sensor? All right, Xener, well, you've got both of us confused now. Yeah, really? Okay, all right. All right, I am... I don't know what to do with that information. So, yes, we are broken. We're very broken. I don't understand that, but you know what? That hasn't stopped us before either, and it's not stopping us now. Wow, okay. I had no idea we were going so far off the deep end. Well, truth be told, I followed the video. So let me scoot back to the top here. And I'm curious to see here if we just jump to the serial monitor section of this. It almost looks like DQ data input output open drain one wire interface pin. That's crazy. We might end up moving our pin to pin 4. Right now I have it on pin 10 because this video said 10. Broken image doesn't tell us anything. Yeah, sensor course. Yeah, right, there's the old URL, learn.inventor.io, sensor training. Well, I'll tell you right now, I'm going to have to send them an email because that is really disappointing that they migrated and nobody bothered to check to see if this still works. All right, nor here nor there. I'm getting distracted. All right, it compiles. Let me turn on the serial monitor and see if we get anything. I'm gonna presume no right now because if I read the code correctly, we're expecting something on pin 4 for data and I have it plugged into pin 10. So real quick, let me just turn on the serial monitor. I'm gonna upload the code and we're gonna see if anything comes out. I'm assuming no. Right, so as it stands right now, we had a very brief blip of gibberish and now there's nothing. So, all right, cool. So that's about what I would have anticipated. So now what we're gonna do is we're gonna scoot back to the top here. And good digital pin, not used for other purposes, is now going to be 10, because that's where I plug the wire in. Gonna verify that. If for some reason it won't read on 10, I will actually move the wire to pin 4. I think we can get away with that. My god, it works! Found one device, and it's spitting back values. I'm not going to lie to you, this is not what I anticipated. It was crazy. Huh. Oh shoot, hold up, need to grab butane. I purposely brought I brought a lighter so that we could make some fire, and then probably forgot to check to see if there was gas in the lighter, so give me a moment. Okay, I have returned. Give me a moment while I refill the lighter here, and then we're going to see some value changes. You sent me an image with the temperature matrix. All right, yeah, let me get that up here, because I am fascinated at this whole thing right now. This evening is not going the direction I thought it was going to go in, but I'm not bothered. Just confused. You know what? That's okay. Digital binary output, hexadecimal output. Okay. Hex codes from what you get to temp. Interesting. Okay. All right. All right. Let me see here. All right, cool. Now that we've got some action, we're going to do a couple things here. I'm going to put the lighter. I'm going to be very careful not to melt the sensor, and we're going to see if there's some changes here. So I'm going to pull up. That's not right. I want that one. There we go. Sorry, everybody. I threw you all out the airlock. There we go. Okay, so these are our values right now, and I'm going to put a little bit of heat near it. And we should see something happen. Very obvious because I did see a little bit of smoke come out of the board. I may have gotten a little too close. It's fine. Okay. Well, thank you very much, Thunder, for popping in. By all means, the VOD will be up. So if you want to see the remainder of the chaos from this evening, by all means, it'll be there. Thank you very much for stopping by. Sleep well. All right. Interestingly enough, I didn't see much in the way of temperature change, but I also don't want to melt the wires. I didn't actually damage anything. I did get a little bit of discoloration briefly, that then immediately disappeared on the jumper parts. So I'm going to do this again. And I'm going to show you what it did. Something else I also want to point out, that I'll have to switch to the bench here, that I didn't know that we were going to have. And that is the light that is on the side. There we go. trying to convince the camera to zoom in. All right, so what I want to show you is that on the side of this little goofy thing, there is a LED, which didn't seem to be noted, but I am once again going to activate said lighter, and carefully put this close to the board, but not too close that I, melt my office down. Go. Okay. Now we have a little bit of flame. I'm going to be careful now this time. I've got 21, 21.25. Okay. Yeah, it is going up. It's going up slowly. All right, cool. I didn't get too hot, too close to that. Now, real quickly, if I just touch this. Yeah, so actually, I mean, it is definitely working. A male to female header. You know, that probably would make my life easier if I did that. That would be a smart protogym would probably have done that. Yes, I think we're gonna do that. Let me switch that out. I may have followed the direction of the video a little too literally, to which I could definitely make this a little easier on myself. But you know, it's what we do. Now, by following the directions of the amazing Xenor, we're going to be a little smart about this and use a header like this so I can get a little closer to the sensor. So then all I should have to do now, save myself from having to meander through the diagram once again, is just do that in an effort to now free us a little bit more from the board. Plug this back in, and we should now get temperature. That is gibberish in my terminal. There we go. All right, I'm getting values now. All right, cool. Now, we are going to see that there's that little standby light I was talking about. So I think that's part of the thing that makes this kind of interesting, is that with the 30 days lost in space, all the sensors were loose, and they didn't have like these pre-terminated boards that we're working with. Not that that's a bad thing, it's a little different because this has an onboard resistor and an onboard LED in addition to the temperature sensor that we see here sticking out of the top of the board, which is okay, but that also then adds a little bit of additional complexity to this that is a little I don't even know the right word I'm looking for here. It's more difficult to reproduce on the breadboard because these are really tiny parts that are part of this little PCB, and I can't just take this sensor and stick it into my breadboard and then attach the LED and resistor. Like, it's all a part of this package. Now granted, if you know that ahead of time, sure, that's fine, but it does kind of remove some of the, you know, yourself into it. Yeah, no, you got a point. That's weird. Why did my chat lock up? But I am going to touch the sensor now, and I'm going to switch this back to the values so we can see that. And we should realistically see over here that if I hold it with my hand, I get hot. And yeah, the values are climbing. We got 29 Celsius, 30 Celsius. We're going to be extra again and see if I can get this close. Not for anything. Let's see if it's interesting how that quickly cools off when you stop touching it. Now granted, it did say it was ambient air, right? And supposedly, according to this, we can have more than one by the way this code is set up. So let me double check and make sure there isn't a and there isn't another one of these in here. Because I was kind of under the impression that there was only one in here of each of these things until I saw a couple of each. A couple of some of them. Let's see here. That's a different sensor. I don't know what that is. Not sure what this is. Is there a part number on it? have to admit, it's a little strange they would have included code for doing. Here. So I've got something that's similar, but it's a lot smaller, which makes me think this is a different type of component. This is a 49 68 isn't Charlie. Yeah, that's a different part number. Huh. Interesting. Alright, like, so as I had mentioned, I probably should switch back to the bench if I want to show you something over here. There we go. That's what I'm working with. So when I tell you I'm like rummaging around in a container, this is literally what they sent me. I mean, granted, I know what some of this stuff is, as I just dropped that that sensor. That's funny. I know a lot of you that are gamers are gonna recognize that one. That's very much exactly what it looks like. But there isn't much in the way of determining which thing is which, other than trying to read the really tiny parts numbers that are on here. So you have to bear with me as I try to figure it out. Which actually makes me wonder how much of an afterthought the obviously you can make an object transparent over another. Oh, you mean to like show the my hang on, camera got messed up. To like show like the temperatures at the same time. Is that what you mean? There we go. I love this camera that I use. Yeah, like the screen of the webcam, for example. All right, cool. That's fair. Yeah, there's always room for improvement. My goodness, it has been an hour and a half. Wow. Okay. That's bonkers. It didn't feel like it was that long already. No, that's right. All right, cool. And neat. Fair enough though. Yeah, I mean, if I continue to want to cycle back and forth between the two, I probably should look into that. I appreciate the hint. But this did work though by me switching this to pin 10. So the video said use 10. The code is written for pin 4. We have a broken diagram. I was able to successfully identify where things were supposed to get plugged in though, which was good. All right. Well, I think we're going to close up that portion of stream for tonight. We're not going anywhere yet, but I did say I want to talk about the proto head. So I think I've done about all I really want to do with this for right now. Added color key filter, and you can change the occupancy. That's the our tech tip for the day. Very nice, very nice. She's coming in clutch with some of the best tips. Appreciate you. Tracking, stop losing tracking. Appreciate you. Oh, okay, cool. Okay. Well, part of the reason why I want to do the sensor thing is to learn more about the Arduino stuff and how you can interact with it. No, I get it. I got it. I have one of their water bottles, actually, the one that looks like a motherboard. It's so much fun. People look at it and they're like, what is that? I'm like, trust me, if you know what you'll know what this is if you do what I do. But yeah, I want to keep tinkering with the sensors in this stuff because we might find something that's cool that might be fun to add to the proto head. I mean, I'm kind of anticipating fairly rigid rails for trying to follow a guided example, but I'm open to different possibilities. But yeah, okay, all right. So this we could save and close this up, and then we're going to close that up because we're done with that.